All right, great. All right, so what we're going to do now is that we're going to do the substitutions. However, remember that we said that y is equals to a to the n, x to the n. We need a summation sign for both. So we're saying it's a summation which goes from n is equals to 0 to infinity, right? And then when we differentiate the summation from n is equal to 0 to infinity, it's going to be the summation from n is equals to 1 now to infinity, right? So let's say they gave you y double prime. This is going to be equals to the summation from n is equals to 2 now to infinity. And then you differentiate this part here, okay?
Why we keep going up
Why we keep going up by 2?
by 1?
By 1? Why is that? It's just, I don't want to really go into the lecture. I'm more have to solve the question. But all right, if we differentiate this, right? If we expand out this one, if we sub n is equal to 0 into this, it's going to be a to the 0, x to the 0, right? But x to the 0 is 1. So it's just going to be a to the 0. And then we're going to have plus a1 x to the 1 plus a2 x to the 2, right? And you continue, and it goes on. So if we differentiate this, this is going to be 0 because it's a constant, right? And then when we differentiate this here, this is just going to be a1, right? And then when we differentiate this, this is going to be 2a2x, right? So remember that from here, this is when n is equals to 0. And this is where n is equals to 1. So therefore, that's where you start, you increase by 1. So when you're differentiating a summation sign, you just increase by 1.
All right.
Okay, so what we need to do now is just to sub everything that we have in here. So y prime is a summation from n is equals to 1 to infinity of n a to the n, and you have x to the n minus 1, and then we have a minus 2 summation from n is equals to 0 to infinity of a to the n. Let me undo that. And then you have a x to the n. And this is equals to 0, right? So the only thing you need to do is to make substitutions for y prime and y. These values are always fixed. You have y is equals to this and y prime is equals to this. So anytime you're solving a power series, you should always have this first, which is what I've highlighted. This is the first thing you should have substitutions for. And then after you have these substitutions, you sub it into the equation in which you have here. So next thing after this now, the next step for us to do is to ensure that we have x to the n only, right? For each expression. So for here, for this one, we realize that we only have x to the n, so that one is good, right? However, for this one here, we have x to the n minus 1. So we need to change this to x to the n. How can we change this to x to the n? We need to make a substitution for n. So if we add 1 to here, it's going to be x to the n, right? Because if you say if you say n is equals to n plus 1, if you put n is equals to n plus 1 here, it's going to be n plus 1 minus 1, which is just going to be equals to n. I hope you guys understand what I'm saying. So what you need to do is that you need to add 1 to where n is, right? To make it x to the n. So if you're going to add 1 here, that means that anywhere you see n, you're going to put n plus 1, right? So you're going to have the summation of open bracket. Anywhere you see n, you put n plus 1 because you need this to be just n alone. So you have n plus 1, and you have a to the n plus 1, and you have x to the n plus 1 minus 1, which just gives you x to the n. And then you have plus, I want to bring the minus 2 on the inside. You should always put anything that you have, like a constant or anything, on the inside. So you have plus the summation from n is equals to 0 to infinity of minus 2 a to the n x to the n is equals to 0. So seeing that we put n where we see n, we put n plus 1. So seeing that we add a 1 to the n, right? We need to minus a 1 from the summation. So we need to minus a 1 from here. So n is equals to 0. And then we need to minus 1 from infinity. But anything minus infinity, it gives you what? It gives you still infinity, right? Someone raise your hand, you can speak. Is there any question?
Yes, you use n plus 1 because you want
This x to the n.
Yeah, to be equal to just n.
Yeah.
So if it was like n minus 2, you will say n plus 2 minus 1. Well, in the series power part.
Yeah, so if this was x to the n minus 2, you just need to add a 2. So anywhere you see n, you put n plus 2. However, for here, it's only you're going to add. But for here, seeing that you put a plus for n, you're going to put a minus 2 for each of these. You understand that part? So if you had x to the n minus 2, you add a 2 to where n is, and then you minus a 2 from the top and the bottom.
Oh, yeah. I think I remember.
Yeah. So we have x to the n on this one, and we have x to the n on this one, right? So that means we're good so far. The next step is to ensure that these two values are the same. So this goes from n is equals, this starts from n equals 0, and this one starts from n equals 0, right? So we're good. So what we need to do now is that we need to put it in one summation. So we're going to come up to here. So what we're doing is that we're combining both of them. So we have a big summation, because seeing that both of them are the same. So a summation of n is equals to 0 to infinity. And then what we have here, we have this first. So we have n plus 1. I have a to the n plus 1. I'm not going to write the x to the n as it, right? Because seeing that x to the n is common between both of them. So I can bring it on the outside. So here now, we have minus 2 a to the n, and then we put x to the n on the outside. And remember, this is equals to 0. Right? So everything is good so far. What you need to do now is that you need to ensure that anything inside the brackets it is equals to 0 because everything is a constant inside here, right? So anytime you have anything in the bracket after you have a big summation, anything inside the bracket is equals to whatever is over to your right hand side, and it's equals to 0. So that we're going to do now. So we need to equate now. So what we're saying is that n plus 1 a to the n plus 1 minus 2 a to the n is equals to 0, right? So after this part, the next step is for us to actually transpose for a variable of a. So seeing that we have an a here and we have another a here, we need to transpose for the one that has a bigger index, right? So which one do you think have the bigger index? It's going to be a to the n plus 1. Because if we say n is equals to 2, this will be a to the third, and this will be just a to the 2, right? So this one have the bigger index. So we always transpose for the bigger index. So this is going to be equals to, we bring this over to the right-hand side, so it becomes a positive. So you have a 2, a to the n, and then we divide it by n plus 1.
Why you had dropped the x to the n again?
It's a rule because what we're doing is
Oh.
that anything inside the bracket is equals to 0. So that's why
Right.
you take out the x.
Just ignore it. All right.
Yeah. So this is what we have so far, right? So we say a to the n plus 1 is equals to 2 over n plus 1 a to the n. All right, so we're almost finished now. What we need to do next is that we need to actually create a table, right? So I'm going to go to a new sheet. So we're going to create a table. So you're going to have values for n. And then if we look back here, where I say a to the n plus 1 is equals to this. So we're going to write it back. All right, so everybody understands so far, right? So what we need to do next is that we need to just plug in any values for n. So I'm just going to create some lines here. So we can say it starts from n is equals to 0, n is equals to 1, 2, 3, we can go to 4. We'll just stop at 4. You can go to any much you want. Just ensure that you have a good amount, right? Well, I want to stop at 4. So what we need to do is that we need anywhere you see n, you put 0. So this is going to be a to the 0 plus 1, which is just a to the 1, right? And why you create a tail is because it's just easier, because you can just go down easily. So if you put 1 into a to the n plus 1, it's just going to be a to the 2. So this is going to be a to the 3, a to the 4, and a to the 5. Then you have equal signs going down. And then we have 2, right? So you have 2 divided by 2 divided by. And now we're going to put 0 for n. So it's going to be 0 plus 1, which is just what? So 0 plus 1. When we put 1 into n, it's going to be 2 plus 2. This is going to be, wait, sorry. I made a mistake. If we put 1 into this, it's going to be 1 plus 1, which is what? 2, right? If we put 2 into n, it's going to be 3. That means that this is going to be 4, and this is going to be 5, right? So the next thing now, we have a to the n. So it's going to be a, I want to put this in red. So you have a naught. If you put 1 into this, you have a1, a2, a3, and a4. So all you do is just sub in values for n is equal to whatever these are into your expression, right? So seeing that we say a1 is 2 over 1 a naught, right? And we know that a2 is equal to 2 over 2 a1. But what is a1 in this case? a1 up here is 2 over 1 a naught, right? So what we're going to do is that we're going to put substitutions in for them. So we're going to write back 2 over 2, open bracket, a1 is up here, and a1 is 2 over 1 a naught. So you have 2 over 1 a naught. Now we come down to this line. We have a3 is 2 over 3 a2. So we have 2 over 3 here. But a2 is where? a2 is up here. a2 is 2 over 2 times 2 over 1 a naught, right? Because we have it here. So that's what we're going to do. So we have 2 over 2 2 over 1, and we have our a naught. A4 is 2 over 4 a3. So we have 2 over 4. And what is a3? a3 is up here, which is 2 over 3. Then you have 2 over 2. And then you have 2 over 1. And you have your a naught, right? And if you actually realize is that everything is in terms of a naught. That's what you should have, right? Seeing that it's such a long process, I'm just going to disregard the 4 because it's too much. So I'm just going to take out the 4. But that's if you want to go to 4, you can do it. But I'm not going to go there. All right, so everybody understand so far? Is there anyone that doesn't understand? Hello?
One lesson for just what to do now after all of that.
All right, good. So I hope you guys understand. And I hope you guys realize that I didn't multiply out throughout. I just leave it as it is, right? So after this now, if you actually go back, we first wrote that y is equal to this, right? Remember that when you're doing second order differential equation, it's the big Y is equals to YC plus YP. So YC is your complementary function, and your YC and your YP, sorry, is your particular integral. So therefore, our answer should be y is equal to something. So we have y is equal to this. So that means that we're saying that this is actually our answer. It is in this form. Y is equal to this. The summation from n is equal to 0 to infinity. Hello? Guys, I don't know what happened to I don't know if it was my internet, but I was just logged off and I came back and I don't see anything that is on the whiteboard. Are you guys seeing what we did previously? Hello? Anyone?
It's breaking.
Boss.
You guys hear me perfectly?
Not really. It was a bit disturbed.
I was asking if you guys saw what we did previously because I'm seeing a blank page now. Are you guys hearing me perfectly now?
Say it again.
Are you guys
You
hearing me
was sounding
perfectly?
clear. Yeah, you're sounding way better now.
All right, good, great. I did some bunch of things on the whiteboard, but I'm not seeing it. Are you guys seeing it? What we did previously?
No.
No.
I'd written down everything down to n equals 3, but I'm not seeing anything on the whiteboard.
All right. All right. If you guys get logged out, just log in back with the same password, okay? All right. So remember that our answer should be, I told you, is y is equals to the summation from n is equals to 0 to infinity of a to the n, x to the n, right? So what we need to do now is that we need to expand this out. So it's y is equal, ooh, what a y. So we have y is equals to, so we put n is equal to 0 into this. So it's a naught x to the 0, but anything raised to the 0 is what? 1. So we're just going to have a naught. Then you say plus a1, because you're going from, you reach at 1 now. You put 1 into this. So it's a1 x, then plus you reach at 2 now when n is equal to 2. Because you're going up to infinity. So it's a2 x squared. Then we have plus a3 x cubed. And we have plus, and it goes on and on and on, right? So what we're going to do now is that we're going to write back the a naught. And then we're going to say plus a1. What did we get for a1? Anybody who wrote it down? Because we're making substitutions for the
2
a's.
2 over 1.
2 over 1,
naught.
a naught, all right. I want to put the a naught in red. A naught, then we have the x. Then we have plus a2 was what?
2 over 2 times 2 over 1 a naught.
And then we have x squared. And the last one, did anyone have A3?
Yeah.
All right,
A3 was 2 over 4.
2 over 4.
Sorry. Yeah, 2 over 4. We did
No,
A2?
no, it has to be 2 over 3.
Yeah, cause you never. Oh, you asked for A is A2. Reach 2 over 3 times 2
2 over
over 2
2. Okay.
times 2 over 1. You know.
We have the A naught multiplied by x to the cube. And then we say t. All right, good. So this is your answer. This is actually your answer, right? However, this is the hard part now. Some lecturers want you to just write this alone because this is actually an answer. However, some of them want you to put it in one big summation, right? So you can leave your answer like this, depending on the lecturer, or you need to break it down more. But if you leave it like this is not wrong. But just in case, you're going to break it down more, right? So if you want to be more fancy or articulate in your answer, you're going to have y is equals to, what we need now is that we need to take out A naught, right? So we have A naught, because A naught is common between everything. And then you have your open bracket. We're going to have the summation now from n is equals to 0, because that's where we started, to infinity. So remember that when we take out A naught into here, this is just going to left with 1. So it's going to be 1 plus 2 over 1 x plus 2 over 2, 2 over 1, x squared, and etc., right? So we're going to look at the numerator. So we have 1, we have 2, we have 2 times 2, we have 2 times 2 times 2, right? So if you make a formula, it's just going to be 2 to the n, right? I hope you guys get that. Because if we take out A naught in each and every one of these, this is going to left with 1. But 1 is the same thing as 2 to the 0. So we have 2 to the 0, 2 to the 2, and this is 2 to the 3. So we're saying that is 2 to the n. We're going to go to the denominator now and realize that these are all factorials. Because this is this is 0 factorial, this is 1 factorial, this is 2 factorial. Because factorial means that if you have 3 factorial, it means that it is 3 times 2 times 1. I hope you guys know about factorials. So we're saying that this is over n factorial. And that's your final answer. So that is how you actually do power series. So again, you can leave your answer like this, depending on the lecture, but if you leave it like this, it is correct. And for this one, it is the same thing. It's just that you put a summation sign in there and actually create a bigger expression. Because remember that this says that it goes on and on. So this covers everything. And that is how you'd actually do power series. Any questions?
Yeah, why use 2n?
Oh, all right. You realize that this is, if you take, remember that we take out A naught into all of these, right? So we take out A naught, which is here. So this would just be 1 plus 2 over 1 x plus 2 over 2, 2 over 1 x squared, right? But remember that we do have a 1 here. So what we do is that we just say 2 to the 0, because 2 to the 0 is same as 1. And then realize that this is 2 to the 0. This is 2 times 2, which is same thing as 2 squared, right? We're looking at the numerator. This is 2 times 2 times 2, which is 2 cubed. So that means we're saying that is 2 to the n.
Right, so it's like you're just following the pattern, like.
Yeah, so you're actually creating a series, what do you call that now? A sequence. So everybody's clear on that? Any questions regarding this? All right, I'm gonna take that as you guys are okay with it then.
Yeah, man, we get it.
Yeah, we're good.
All right, good. This goes a long way because there are really more complex ones for power series. But if you guys say you guys are okay with this, you just use this criteria and you can apply it to any form of power series. It's just that there's some little tricks there if you get a hard question to do. All right, suppose we had 1 over d squared, let's see, minus 2d plus 1. And we have x squared cos x. Does anyone know how to do that one?
No.
This was a past paper question 2 years ago, and everyone found difficulty in doing it. Because if there was an e in there, you could know that you just do a direct substitution in here and whatever, right? But this one is a bit hard, and I'm sure that you'll probably get something like this in the examination. I'm not too sure. However, this might come up, right? There's something known as Euler's identity. I'm not sure if you guys know about Euler and complex numbers, but his formula states that it's e raised to the ix is equals to cos x plus I sin x. So what we're saying is that cos x is the real part and I sin x is the imaginary part because we have an I here. So we're saying that sin x is imaginary while cos x is the real part, right? So what we're saying that is that we're actually saying it is 1 over d squared minus 2d plus 1 times x squared. And for the cos x now, it's going to be the real part of e to the ix. Everybody get that, right? So you know that when you have e and you have a variable, the only thing you need to do is to bring the e over to the left-hand side because we finished with that. So we're saying that it's the real part of e to the ix, and you have the 1 over. So when we have d, we're going to say d plus I because I is here. If it was 2, it would be d plus 2. So this would be d plus I squared minus 2 d plus I, and you have your plus 1. And all of this would have x squared. I hope you guys know the rule for this though. Like when you have an e and you have an x, so you bring the e over, and then anywhere you say d, you put d plus whatever this here is, and this is I, so you have it here. So what we need now is that seeing that this has an x squared, you know what to do. You need something like 1 over 1 plus d, or something like 1 over 1 minus d. And you use the expansion for this. I won't continue though because it can get really complex. So just research this and see how you actually use or try to solve a question like this, right? Oh, somebody asking me which rule was that. It's a rule where you, all right, if you have anything, like, you know that you'll have 1 over anything, like you will have a d form, because let's say you have d squared plus 1. If you have e raised to the x, you do a direct substitution for here. So we're saying that anywhere you see x, where anywhere you see d, you put a 1. However, suppose you have e to the x multiplied by something else. Let's say you have x to the cube, right? Or e to the x cos x or anything. This is going to be different. Where you say d, you're going to put d plus 1 because there's a 1, imaginary 1 here. So you're going to be d plus 1 all squared plus 1. It's a rule that you guys should actually know. So it's the same thing up here. You have to use complex numbers in order to solve a question like this. So hopefully they don't give you a question like this because it can get really complex. However, as I said, it was on a past paper question. So just pray that you don't get something like that, right? All right, so that's just what I wanted to show you guys. So back to the Cauchy-Euler. 1 second, guys. All right, Cauchy-Euler now. I'm looking at trying to look at a past paper or the tutorial sheets. It's Cauchy-Euler. All right, here's some Cauchy-Euler question. To be honest, I was looking at the tutorial sheet and I was a bit disappointed in a way because it's not really, it doesn't show as much because based on other person's experiences, especially mine, it will get more complex, especially when it comes to finals, right? So I think they will give you even harder questions like these or harder question than these. However, hopefully you use the same concept. So I'll just use a random one, probably a hard one that I could actually try, and it's this one. So this says it's x cubed e cubed y . One second, guys. I'm just trying to find the toolbar, guys. 1 second. All right. By the way, you guys understand my handwriting, right? It's not too bad.
No, it's good. We get it.
All right. Wait, what am I writing? X squared. It's supposed to be a squared. And they shouldn't have any here. All right, you know what? I'm gonna just write it back over. All right, so they gave you a question like this, right? The first thing you should ask yourself, how will you know that this is a Cauchy-Euler differential equation? How you would actually know is if they have the same powers. Whereas this has an x squared and you have a square here. This has an x to the power of 1 and this has a power of 1 here, right? So that's how you'd actually know. So this is actually a Cauchy-Euler differential equation. The first thing in order to solve a Cauchy-Euler is that you need to make substitutions. So the first thing we need to know is that we need to make substitutions for dy by dx and d squared y by dx squared, right? So what we're saying is that dy over dx is equals to del y. Some people use d, some people use anything. So I'm just going to use del y. So what we need now is we need del squared.
Can you use D?
You want me to use d?
Yeah.
All right.
I'm just used to D.
So we have dy, right? That means say d squared y over dx squared is equals to d open bracket d minus 1 y. These are all set equations. So that's the first thing you should always do. It will never change. So anytime you're solving a Cauchy-Euler, this is what you should do first, right? Then we need to make substitutions for x. So we're going to say that x is equals to e to the z. And if we ln both sides, this is going to be ln of x is equals to z. So when you say ln x, you put ln x here. When you say ln e to the z, you drop down the z and ln e is 1. So that's why you have ln x equals to z, right? So these are the 4 things you should always have. And now we can actually get to solve the expression or the equation. So, sorry, this is supposed to actually be an x here. And it's supposed to be an x squared. So these are the formulas you need to write down. So memorize or sort it. So we can use the equation now. So we say that x squared, d squared y by dx squared is d, which is, we're going to write it here. So we have d, open bracket, d minus 1. Then we have minus 3. And then we said x dy by dx is dy, right? So we have a d. You guys realize that I'm not putting in the y, right? Seeing that y is common between everything, I'm going to put it on the outside. And then you have a plus 4. And then you have a big bracket. And you have your y. And this is equals to 6. Now, x squared. Remember that x is equals to e to the z. So if we square both sides, if we put a squared here, and we square this here, it's going to be e to the 2z. I hope you guys see that. Seeing that x is equal to e to the z, when we square it, it's equal to e to the 2z. So everything we have to rewrite in terms of z. So let me take this back. And now we have ln x. Remember that ln x is equal to z. So we're going to multiply it by z. And then we're going to say plus 6. And then we have x again is e to the z. So we can actually bring it up. So it's going to be e to the minus z. I want to write the 6 much better. This is a 6. So what we need to do now is that remember that we need to find the complementary function. So what we need to do is that we need to change all of these. We need to expand out all of these first. So this is going to be equals to d squared minus d minus 3d. We have our plus 4. And we have our y. And this is going to be equals to 6e to 2z multiplied by z. So 6 to the e to the minus z. So we're just going to break this down. So the next one is going to be d squared minus 4d plus 4. And we have our y is equals to. And when we go back now, we have this here, which is 6e to the 2z multiplied by z, and we have plus 6e to the minus z. right? So remember that there's something called its auxiliary equation, right? So with its auxiliary equation, we need to change these to m. So now we're going to say m squared minus 4m plus 4, and it is equal to 0. Because what is happening is that we just change these to m, and then we're just going to equate it to 0. Because what we're trying to do is that we're trying to find the complementary function, right? So we need to actually either use a quadratic formula to find m, use completing the square, or we can factorize it. Can it be factorized? I think so. So what we would have is m squared. So if we have 1 multiplied by 4, it's 4. So we can have minus 2 and minus 2. So minus 2m minus 2m plus 4. And it is equal to 0. So all we're doing is that we're actually just trying to solve for m, right? So I hope you guys already know to factorize. So our answer here is that m is equals to what? M is equals to 2, right? So realize that, all right, let me just write 2 and 2, which is the same thing. So realize that m is equals to 2 and 2. So there's a formula for complementary function when there's repeating terms. I'm going to write the formula. I hope you guys know it. So remember that this is a complementary function. This is equals to, open bracket, C1 plus C2. We usually write an x here, but remember that we transfer the x into z up here, right? So we need to write a z here. And then we're going to write e to the minus, x was supposed to be here again. Wait, this shouldn't be minus, I'm sorry. X to the, let's say, m. And then x should be here, but it's supposed to be z because you transfer all the x into z. So our answer for the complementary function, yc, is equals to C1 plus C2. I remember that what we did for Z. What did we have for Z? Z over the other side. Z was what? Z was ln x. So we have ln x. And then you have e to the 2z, right? It's supposed to have e to the 2z because m is 2. However, if you write e to the 2z, right? For here, if you have e to the 2z, that means that here should be a x squared. So this should be x squared. And this is your answer for the complementary function. However, we're not finished because remember that our final answer should be the complementary function plus the particular integral, which is yp. So now we need to find yp now. So what we have here, we're going to add it to yp. All right, so I want to move on to a new page. Or we could actually do it here. It's fine. I'll just do it here. I'll just draw a line. So to find YP now, we're going to have YP, but we're going to have YP1 because we're going to have two YP. We're going to have a YP for this. We're going to have a YP for this here, which is YP1, and we're going to have another YP here, which is YP2. So it's going to use this one first. So it's, remember, it's 1 over whatever we have here for D. So this is D squared minus 4D, and this is plus 4. And then we're going to raise it to 6e to the 2z times z. Multiplied by z, right? So remember, once we have an e multiplied by something else, we're going to take out it. We're going to take it out. So we're going to put the 6e to the 2z over this side. And we're going to have 1 over. So anywhere you see d, you're going to put d plus 2. So we have a 2 here. So we have a d plus 2 squared minus 4 d plus 2, and you have a plus 4. And remember that you have a z here, right? Does everyone understand so far? Is there anything that you guys don't understand for the Cauchy-Euler so far? All right, so I'm guessing you guys are
I
good.
understand, we're following.
All right, good.
Mhm.
It's just that this question is so long. What we need to do now is that we need to expand this. So let us use our mind and expand this part, right? So this is going to be, remember it says d plus 2 all squared. So it's d plus 2 multiplied by d plus 2. So it's going to be d squared plus 4d plus 4 for here. So we have 6e to the 2z, 1 over d squared plus 4d plus 4. By the way, this is the last example that we're going to do. So once we finish with this, we're going to just end it for the day. If we go back now, we have a minus, so we're going to expand the 4 now. So it's minus 4d minus 8. And this is going to be plus 4. I remember that you still have your z here. 1 second, guys. My laptop is dying. I need to charge it. 1 second. All right. So we can simplify now. Remember that this is YP1. So this now is going to be 6e to the 2z of 1 all over d squared. So look at this. This is 4d and this is minus 4d. So what we're saying is that those two cancel. So this is 4d and this is positive 4d and this is minus 4d, right? So those two cancel. We have plus 4 and we have plus 4. Those are 8. And we have a minus 8. So it's 8 minus 8, which is 0. So those two cancel as well. So you're actually only left with d squared. So I didn't have to draw the line so far then. So it's 1 over d squared and you have the z. Right? So next we're going to write back the 6e to the 2z. And look at this now. When you have 1 over, remember that the d means that you're going to differentiate. So when you have 1 over d now, it means that you're actually going to integrate, right? But however, you're going to integrate 2 times. So you have a d squared. So we're going to multiply it by, so when we integrate z, it's going to be what? It's going to be z squared over 2, right? And then when we integrate it again, which is you're going to add a 1 to the power and then put it down here. So it's going to be z cubed over 2 times 3, which is going to be z cubed over 6, right? Everybody get that one, right? So all you do is that you're going to integrate z 2 times. So remember, we're going to integrate it. So it's going to be z squared over 2. So you add a 1 and then divide it by whatever the power is. And then you're going to integrate it again. And you get 1 over 6 z cubed. So here you're going to have 1 over 6 z cubed. And now we realize that this 6 cancels this 6 here. So what you're left with is e to the 2z multiplied by z cubed, right? And this is your yp1. However, we need to write it in terms of x. So so the first one we have is e to the 2z. So we're going to go back. Remember that this is e to the 2z. So what they did was that they squared this. So that means we need to square this as well. So this is actually x squared. So this is saying it is x squared. And z cubed now, what is z? Z is actually ln x, but it's cubed. So it's going to be ln x all squared, all cubed, right? Ln x to the 3rd power. Ln x raised to the 3rd power. So we have yp1. Now we need to find yp2. Yp2 is what we're going to find here. So which is 6e to the minus z. And we have the 1 over, so this is our yp2. What did we have? D squared. If we go back here, what we had was d squared d squared minus 4d plus 4. So seeing that this is e to the minus z, and there's nothing multiplied by the e, right? Like a sine or a cos or x. We just do a direct substitution. So what we're saying is that D is equals to -1 because this is as a -1 here. So all you do is a direct substitution.